Okay, so hello everyone. Welcome to another interesting session of the Astro Club. So today we are going to learn a very important and a very interesting topic, that is quasars. Okay, so today our topic name is quasars. So let's see what quasars are. So before we get into today's topic, there's a riddle for you all. What object in the galaxy is like a star but isn't a star? Can anyone try to answer this riddle? What object in the galaxy is like a star but isn't a star? Do you have any idea about it? Okay, no problem. We can discuss in today's session. Okay, so today let's find out all about these almost stars. So they are all almost stars. They are not exactly a star. They are almost stars. So let's find out all about these almost stars and learn what astronomers think the answer to this riddle might be. So let's find out about that. So almost 90 years ago, so here's a small story, try to enjoy it. So almost 90 years ago, a man working for a telephone company was trying to figure out what was making the static or the cracking type of noises that were being heard on the phones. So, in the olden days, there used to be this type of phones. So while they were speaking to other person through these phones, they used to hear some crackling noise. Sometimes nowadays also we hear some type of noise in our phones when signals are not proper, right? So one man heard those type of crackling noises and he wondered where the sounds might be coming from. He thought that the sounds seemed to be coming from outer space. So what did he think? He thought that these sounds were coming from outer space. But what was making them crack like that? So he did not find any answer. He just thought that those sounds might be coming from outer space. So then later astronomers, that is the scientists who study about stars and other objects in the universe, they found that these noises seem to be coming from stars that were very far away. So later astronomers, what they found that those noises were coming from the stars that are located very far away. So because of the noises they made, which were like radio waves, these objects were first called as radio stars. Okay, so the sounds that these objects made were like the same as the sounds which the radio waves make itself. So therefore, they call these objects as radio stars. At first, they used to call these objects as radio stars. Okay. So as you can see in this slide, these are the radio waves we have discussed in the electromagnetic spectrum. Did you remember?
Yes, Akka.
Yeah, we've discussed this picture in the electromagnetic spectrum. Okay, yeah. So initially, those objects were called as radio stars. So in the 1960s, using more advanced telescopes and other equipment, astronomers realized that the brightly shining objects that were sending out these radio waves, they weren't actually stars. So a few years later, in the 1960s, what these astronomers found out, they found out that there were some objects in the universe that were sending out the radio waves. First, what they thought that those objects were stars and they named as radio stars. But later they found out that they were not actually stars. Like they had the property of stars, but they are not actually stars. So in some ways they were like stars, but in other ways they are different. So for this reason, these objects were renamed as quasi-stellar radio sources, or quasars for short. So there were some objects in the universe that were like stars in some ways. Like in some categories, they resembled stars. In some categories, they were not like stars. So astronomers named them as quasi-stellar radio sources or quasars. So the answer to the riddle that I've shown you at the beginning, what object in the galaxy is like a star but isn't a star? So the answer is quasars, the topic of today's session. Yeah, so that is the answer for this riddle. So they are like stars, but they are not actually stars. So they're called as quasi-stellar radio sources. So quasi-stellar, this word sounds something complex, right? So let's learn what is the inner meaning of this word. So quasi means something is like something else, but not quite the same. So if you observe this sentence, this looks like some tongue twister or something. So something is like something else, but not quite the same. So quasi means that. So stellar means stars. So finally, quasi-stellar means objects like stars, but not the same. So they are the objects that look like stars or that have the characteristics of stars, but they are not exactly stars. So that is the meaning of quasi-stellar. Okay, are you all able to understand?
Yes, ma'am.
Yes, Akka.
Yeah. So now we're going to discuss about quasars and black holes also, because there is some interconnection or there is some relationship between the quasars and black holes. So let's see what it is. But before going to the formation of quasars and all of that, we must first understand what is a black hole. So we should first understand what is a black hole. So we know that space is a pretty dark place. So an entire space is like really dark. Even so, some areas are darker than the others, but nothing is darker than a black hole. So a black hole in the universe, so nothing is darker than a black hole. So it is very dark. A black hole is an area of immense gravity. So the black hole has immense gravity that nothing, not even light, can escape from it. So this black hole is very dark, like very black inside, and it has immense gravity, very strong gravitational influence. That nothing, not even light, can escape from the black hole. Once the light goes in the black hole, it can never come out. It can never escape. So that is the power of the black hole. So black holes form at the end of some stars' lives. So after a star dies, like at the end of stars' lives, these black holes form. So the energy that held the star together disappears and it collapses on itself, producing a magnificent explosion. So when the star was alive, it has massive amount of energy in it. But once the star dies, all that energy gets collapsed and gets concentrated at one place and forms a magnificent explosion. So what is that explosion? It is nothing but this black hole. Yeah.
Black hole.
Yeah, so to understand about the black hole much better,
Akka,
I have a, yeah.
if we go on to the black hole, we will never come again.
No, yeah, you will never come out. Okay, so to understand much better about the black hole, I have a video for you all. So first, let's watch that video. Yeah, so this is actually a small rhyme. Let's watch it. So is it visible and audible?
Yes,
Yes,
Akka.
Akka.
Yeah.
Watch out, I am a black hole, the giant monster of space. Boom, boom, star explosion, here I am a black hole. Watch out, I am the strongest. Watch out, I am the toughest. Watch out, if you come too close, I'll swallow you right up.
Watch out, I am a black hole, the giant monster of space. The biggest, strongest of them all. Better stay away from me. Watch out, I am the strongest. Watch out, I am the toughest. Watch out, if you come too close, I'll swallow you right up.
Oh no!
Yeah, so did you listen to the rhyme?
Yes, sir.
Yes,
So,
sir.
yeah, so what is that black hole saying? It is saying that it is the strongest and it is the toughest of all the objects in the universe.
And it can
Yeah.
swallow anything.
Yeah, it can swallow anything. So it's saying better stay away from me, because if any object comes near the black hole, it will swallow it.
And it is the biggest of the universe.
Yeah. So, okay. So I have another rhyme also based on black hole. So let me show you that one also.
Okay.
Okay, so let's listen to another rhyme. Yeah. So in this rhyme, you can clearly, in this song, you can clearly understand still some more information about black hole. Okay, listen to this carefully.
Black hole, a region in space.
So is it visible and audible?
Yes, Akka.
Yeah.
Yes, sir.
Okay, now listen to this song. You get a lot of information here.
Where gravity is so strong nothing can escape. Black hole, you know that place where matter is squeezed in a tiny space. Black hole, a region in space where stars collapse and fade away. Black hole, you know that place where matter disappears without a trace. Ever wonder what happens when a star collapses?
A black hole!
Gravity starts pulling and all the matter gets trapped in, never to be seen again. Like water going down the drain when you pull the plug in the tub. It's insane how a black hole pulls all the matter around into a region of space that can't be found.
A giant star casts out its outer layers, leaving the core, which collapses in on itself and forms a black hole.
Black hole, a region in space where gravity is so strong nothing can escape. Black hole, you know that place where matter is squeezed in a tiny space. Black hole, a region in space where stars collapse and fade away. Black hole, you know that place where matter disappears without a trace. There are three types of black holes: stellar and supermassive and miniature.
Whoa! So a black hole can be small?
As tiny as one single atom.
That's all?
Yeah, but they can be really big too. Supermassive black holes are the ones that are super huge, and then stellar black holes are the ones that come from dying stars much bigger than our sun.
Sagittarius A is a supermassive black hole in the middle of the Milky Way. We will never reach it because we are too far away.
Black hole, a region in space where gravity is so strong nothing can escape. Black hole, you know that place where matter is squeezed in a tiny space. Black hole, a region in space where stars collapse and fade away. Black hole, you know that place where matter disappears without a trace.
Okay, so did you listen to that song?
Yes, Akka.
Akka, I have a doubt.
Yeah, okay, tell me.
Akka, what are those three types of black holes?
Yeah, they mentioned it in the video, right? So there are three types of black holes. They are stellar, supermassive, and miniature. Stellar black hole, supermassive black hole, and miniature black hole. Okay?
Yes, sir.
Okay, so now let's go back to our presentation here. Okay, so we have learned
What is the third type of black hole?
miniature black hole. First one is the stellar, second one is supermassive, third one is miniature. Okay, so we have learned what a black hole is. Okay, so now listen to this carefully. Every galaxy has a supermassive black hole at its center. You can probably tell from the name that a supermassive black hole is huge. So in the name itself, it is a supermassive black hole. So it's very huge. So in that name, if you see there in the word supermassive, so what does massive mean there? Or what is mass? Let's see. So mass is how much stuff something is made out of. So supermassive in the sense there's a lot of stuff inside that black hole. So it's very huge. So that's why we call it as supermassive black hole. So black holes are full of, like black holes have lots of stuff in them. and this stuff is tightly packed together, which means it is very dense. If a black hole has lot of stuff inside, it means that that black hole is very dense. Okay, are you able to understand?
Yes, sir.
Yes, sir.
Yeah. So, when gases flow into the supermassive black hole, the gas becomes very, very hot. So, this makes it glow. So, why is this black hole glowing like this? Because when the gas enters the black hole, it becomes very, very hot. That's why it is showing that glow. Okay, is it clear?
Yes,
Yes, sir.
Yeah. So the particles of dust and gas that stream away from the black hole are moving extremely fast. So scientists believe that it is this glowing gas edge of the black hole that gives energy and light to a quasar. So how is quasar formed? So since the black hole is glowing, so the glowing edge of the black hole gives energy and light to a quasar. So scientists believe that. So what can we conclude? We can conclude that a quasar is always found near a supermassive black hole. Okay, so the final conclusion is a quasar is always found near a supermassive black hole. So how does the quasar get its energy? Because of the glowing edge of the supermassive black hole. The supermassive black hole glows, right? We have talked about it. The gas enters, it becomes very hot.
Yes, sir.
Yeah, that's why this supermassive black hole glows. And the glowing edge of the supermassive black hole gives energy and the light to the quasar. So that's why a quasar is always found near a supermassive black hole. So since their discovery in the early 1960s, quasars or quasi-stellar radio sources, they continue to baffle astronomers. So it's generally, they continue to baffle astronomers. It is now generally accepted that quasars are the highly luminous cores or the nuclei of distant galaxies. So what exactly are quasars? Quasars are the nuclei of distant galaxies. They are not of our galaxy. They are of other galaxies. Other galaxies' nuclei appear to us like quasars. Okay, did you all understand?
Yes, sir.
Okay. Yeah. So now, I have a small video for you based on quasars. So let's watch that video to get some more complete information. Okay.
Yes, sir.
Okay.
Okay, so let me show that video to you.
Quasars are the most
So is it visible and audible?
Yes, sir.
Yes, sir.
luminous objects
Yeah, okay. Listen to this video. It has a lot of information on quasars.
in the universe. Now, astronomers using the European Southern Observatory have found a quasar that's more than 5 times more powerful than any previously seen. Astronomers on Earth first became aware that quasars existed in the 1950s. Back then, the term quasar meant quasi-stellar radio source because they looked like very bright points on the sky at radio frequencies. Now, we've come to understand that they are actually gargantuan sprays of matter and energy powered by supermassive black holes in the centers of young galaxies. Wait, I hear you say, don't black holes suck matter in? Well, sure they do, but as they do, they tend to shred that matter apart, spinning it up, forcing it outward at very high speeds. Researchers have cataloged more than 200,000 of these objects. The very nearest one is more than 600 million light-years away from Earth, and most are at least 3 billion light-years back in space-time. But this discovery is the first to confirm the theorists' predictions that these cosmic blowtorches could truly be this hot and this bright. For Space.com, I'm Dave Brody.
Yeah. Okay, so did you understand about quasars?
Yes, Akka.
Yes, Akka.
Yeah, okay. So this is the topic for today's session, that is quasars. So this is all the information about quasars. So I hope you've understood today's session.
Yes, sir.
Yeah, and anyways, I'll be uploading this recording of today's sessions in the YouTube, and I'll share the link also. You can watch that later on. Okay, yeah. So that's the end of today's session. Thank you all for joining. You can leave.